Hello there, my name is Ajiboye Isaac. Today we want to learn another area of inequality, and that is absolute value. Don't forget, we started discussing inequality about 3 notes ago. So this time around we want to look at absolute value. How do we interpret or solve problems of absolute value? Our learning objectives. At the end of the lesson, learners should be able to define absolute of a number x denoted by absolute x. That symbol double slash x in between is what we refer to absolute. Okay, and also learners should be able to interpret absolute of a number x using basic fact about absolute, and therefore apply basic fact of the absolute to determine the solution set of linear absolute inequality in one variable. In all further maths exam, you'll come across absolute values. So it is therefore important that you know how to interpret and solve problems of absolute expressions. Key vocabulary words. Inequality. It is a relation comparing two relatable quantities. It can be greater than, less than, or equal to. Inequality signs. Less than. It's just like you fold your left elbow. Negative. If a is less than 0, it can be interpreted as a is negative. So when we say a is less than 0, we simply mean a is negative. Greater than 0, it's just like you fold your right elbow. And positive, if a is greater than 0, it can be interpreted as a is positive. We also have less than or equal to, and then we also have greater than or equal to. These are key vocabulary words that we need to watch out for in our notes. Absolute value. If a number x is positive, the absolute value of x is denoted by x absolute, and that is x itself. If a number x is positive, the absolute value of x denoted by absolute x is x itself. If a number x is negative, the absolute value of x is also minus the x, or the negative x. The absolute value of x, sometimes called modulus of x, is defined precisely as absolute of x is equal to x when x is positive and minus x when x is negative. That is, absolute value of x is equal to x when x is greater than 0 and is equal to minus x when x is less than 0. Thus, the absolute value of a number gives the magnitude of the number regardless of the sign. So if I say the absolute, for instance, the absolute of minus 3 is 3, and the absolute of plus 3 is 3. So we don't really regard the signs, whether be it minus or plus. We just take the magnitude, just the magnitude of the value, right? So again, we have basic fact about absolute. If absolute x is less than p, then x is less than p if s is greater than or equal to 0, or minus x is less than p if x is less than 0. Therefore, if x is greater than minus p, therefore x is greater than minus p if x is less than 0. Hence, if absolute x is less than p, then our x is between minus p and p. I'll say that again. If x is less than minus p, if absolute x is less than p, then our p is between minus p and p. Basic fact B. If absolute x is greater than p, Then x is greater than p if x is greater than 0 or equals to 0, or minus x is greater than p if x is less than 0. Therefore, x is less than minus p if x is less than 0. Hence, if absolute of x is greater than p, then x is greater than p or x is less than minus p. Absolute value C. Absolute fact C. If absolute of x minus b is less than q, then x minus b is less than q if x minus b is greater than 0. Therefore, x is less than q plus b when you take the minus b to the other side. Or minus, open bracket, x minus b, close bracket, is less than q if x minus b is less than 0. X minus b is greater than minus q. It therefore means x is greater than b minus q. Hence, if x is less than p, then b minus q is less than x and is less than b plus q. So, let's look at the example. Find the solution set of 2x minus 3 absolute less than or equals less than 4. We have said that if 2x minus 3 is less than 4, we said that 2x minus 3 is less than 4 if 2x minus 3 is greater than 0. That is plus. And then if we solve that, 2x minus 3 is less than 4, meaning that 2x is less than 4 plus 3. That means x is less than 7 over 2. Also, it can as well be minus, open bracket, 2x minus 3, close bracket, less than 4 when 2x minus 3 is greater than minus 4. So, if you multiply both sides by minus, you have 2x minus 3 is greater than minus 4. And then x will be greater than minus 1 over 2. So the solution set is x such that minus 1 over 2 is less than x is less than 7 over 2. And that can be displayed on the number line as such. Solve the example. Find the solution set of 3x minus 2 greater than 4. Then 3x minus 2 greater than 4. If 3x minus 2 is positive, therefore, we say 3x minus 2 greater than 4. When we take the minus 2 to the other side, it becomes 3x greater than 4 plus 2. And so 3x is greater than 6, and therefore our x is greater than 2. Or minus, open bracket, 3x minus 2, close bracket, greater than 4. So that 3x minus 2 is less than 0. 3x minus 2 is less than minus 4 when you multiply both sides by minus. And then 3x less than minus 4, such that x less than minus 2 over 3. Therefore, the solution set is x such that x is less than minus 2 over 3 union x such that x is greater than 2. And then we take the union of the two solution sets. Classwork. Please follow the example to be able to solve the classwork and forward your attempts of the classwork to my WhatsApp number. And also show your attempt of the assignment. Forward your attempt of the assignment to my WhatsApp number. I'd like to commend the effort of those that did the previous assignment. Keep it up, you're on the right path. And let me also state that you can subscribe to my YouTube channel for notification of new video uploads. On a regular basis, I upload videos on different topics in further mathematics and mathematics. And then you can as well share and recommend to your friends who are also learning mathematics and further mathematics. You can as well comment on the videos to tell us how the video has helped you. What the improvement are you looking out for? Are you looking forward to? And also, we render private lesson for those who are in need of it. So you can contact us for private tutor. We're more than willing to be of service. Thank you for listening.